Hello students, now we are going to discuss how to find the angle between two lines given. So first let us revise the idea how to find the relationship between the direction cosines and direction ratios. In our previous video we discussed that L by A is equal to M by B is equal to N by C. Here L, M, N, these three are the direction cosines, whereas A, B, C are the direction ratios. We can say this value is equal to some lambda, where lambda is the proportionality constant. Now if we take it, L is equal to A lambda, M is equal to B lambda and N is equal to C lambda. From this we found lambda is equal to 1 by square root of A square plus B square plus C square. Already we found it in our previous video. With the help of this we can say the values of L, M and N as A by square root of A square plus B square plus C square, and M is equal to B by square root of A square plus B square plus C square, and N is equal to C by square root of A square plus B square plus C square. Now we have these three values L, M, N. We are going to find the formula for finding the angle between two lines. Suppose take the three-dimensional plane. Say this is x-axis, y-axis, whereas this is z-axis, this is origin. Let us take two lines passing through the origin. Say this is one line, say another line which is passing through the origin. These two lines L1, say let us take capital letters L1, L2 for the two lines. These two are passing through the origin and making the angle theta. Now we want to find the angle between these two straight lines L1 and L2. So we use the formula cos theta is equal to, here the two vectors are B1 vector and B2 vector, find their dot product, divided by the modulus values of each vector should be found as the product. That means cos theta is equal to B1 vector dot B2 vector divided by modulus of B1 vector into modulus of B2 vector. This is a general formula for finding the angle between the two straight lines. Okay, now let us take B1 vector as A1i plus B1j plus C1k. Similarly, B2 vector is A2i plus B2j plus C2k. When we find its modulus, modulus of B1 vector is equal to square root of A1 square plus B1 square plus C1 square, and similarly modulus of B2 vector is square root of A2 square plus B2 square plus C2 square. Now let us substitute these values in this. Before that we can find B1 dot B2. B1 dot B2 is equal to, in the dot product we have to multiply only the I with I, j with j, k with k. We should not multiply with other values. I should not be multiplied with j because both will be perpendicular. When two vectors are perpendicular, automatically cos theta value, that is cos 90, will be 0. So we will not get the value. So we take A1 A2 plus B1 B2 plus C1 C2. Now we have got B1 vector dot B2 vector is equal to A1 A2 plus B1 B2 plus C1 C2. This is a scalar product. Let us substitute all the three values in the formula cos theta is equal to B1 dot B2 divided by modulus of B1 B2. So we get cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 whole divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So this is the final answer we have attained. So if you want to find the angle between two vectors, you should use the formula cos theta is equal to the direction ratios a1, b1, c1 are the direction ratios of the first vector, a2, b2, c2 are the direction ratios of the second vector. Substitute them in this formula, that is a1, a2 plus b1, b2 plus c1, c2 whole divided by square root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So here we have got this formula when the direction ratios are given. And remember, already I said you that L is nothing but a by square root of a square plus b square plus c square. Suppose we have two sets of direction ratios, that means the direction cosines. The direction cosines of the first vector and the direction cosines of the second vector are given. Then we will have L1, M1, N1 as the first set of direction cosines of the first vector. Similarly, L2, M2 and N2 are the direction cosines of the second vector. So here L1 vector will be changed as A1 by root of A1 square plus B1 square plus C1 square. Similarly, L2, M1, M2, N1, N2, when we substitute all these values here, we will get the same. That means we will get the new formula, that is cos theta is equal to L1, L2 plus M1, M2 plus N1, N2. Remember, L1 is nothing but A1 by square root of A1 square plus B1 square plus C1 square. L2 is nothing but A2 by root of A2 square plus B2 square plus C2 square plus here M1 value, that is B1 by square root of A1 square plus B1 square plus C1 square. Similarly, the remaining values. When we substitute all these values here, we will get this form into another form, that is cos theta is equal to L1, L2 plus M1, M2 plus N1, N2. Now we have two different formulae. When direction cosines are given, we have to use this formula. When direction ratios are given, use this formula to find the angle between the two lines. And now suppose the two lines are parallel lines. When two lines are parallel lines, then we have this condition, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. That means their direction ratios are proportional. When the two lines are parallel, two conditions we can say, the direction ratios are proportional or direction cosines are proportional. Suppose the direction cosines or direction ratios are given, we are asked to find whether the lines are perpendicular or not. It is very simple thing. When they are perpendicular, automatically the value of theta is equal to 90 degree. When cos 90 is found, cos 90 is equal to 0. So we will get the condition A1 A2 plus B1 B2 plus C1 C2 is equal to 0, or say L1 L2 plus M1 M2 plus N1 N2 is equal to 0. So when two lines are perpendicular, the condition is this A1 A2 plus B1 B2 plus C1 C2 is equal to 0, or we can say L1 L2 plus M1 M2 plus N1 N2 is equal to 0. So these formulae can be used to find the or check whether the two lines are parallel or perpendicular. So now in this video we discussed one main point, that is how to find the angle between the two straight lines. First one, we have to find the angle between the two straight lines when the direction ratios are given. We use the formula cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 whole divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Just pause the video to note down the formulae. I will write all the formulae on the board again to revise. Cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square when direction ratios are given. When direction cosines are given, then we have to use a formula cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. Suppose the two lines are parallel, the condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. When the two lines are perpendicular, the condition is L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Note down all these conditions. Now we will solve a problem to find the value of some constant given. Please pause the video and note down all the formulae. Now let us take a question. Here the equations of the straight lines are given, that is first one 1 minus x divided by 3 is equal to 7y minus 14 divided by 2p is equal to z minus 3 divided by 2. This is the equation of the first straight line. And another one is 7 minus 7x by 3p is equal to y minus 5 divided by 1 is equal to 6 minus z by 5. They are telling that these two straight lines are perpendicular to each other, or they are meeting at the right angles. Very simple thing. First we should write both the equations as they are, and then next we have to see whether the equations are in the proper order or not. In the previous model itself I told you how the equations should be. If the straight line is passing through one point and parallel to a vector b vector, then I said you the formula x minus x1 by small a is equal to y minus y1 by small b is equal to z minus z1 by small c. Here it is not in the proper order. So we are changing the equations in this way: x minus 1 by minus 3. So I take this minus xx plus x, so automatically that minus I bring down is equal to, from this we want only y, so with the 7 we can divide the numerator and denominator, so that the numerator will become y minus 2 and here it will become 2p by 7. Okay, it is equal to, here z minus 3 by 2, there is no change at all, we can write it as it is. From here, say this is a1 is minus 3, b1 is 2p by 7 and c1 is 2. From the first equation we have got the direction ratios. Let us write the second equation. Here it is not in the proper order. 7 minus 7x is there, so we can take this 7 common, and here x is negative, x must be positive, so we can take minus 7 outside. So we can write this as x minus 1, that minus 7 will be taken to the denominator, so 3p by 7, that will become minus 3p by 7, minus 3p by 7 is equal to, from here no change needed, that means y minus 5 it is in the proper order, no change, whereas the last one it is not in the order, it is 6 minus z, so we are changing this as z minus 6, so that minus can be brought down, so 5 will be changed to minus 5. Here a2 is equal to minus 3p by 7, b2 it is equal to 1 and c2 is equal to minus 5. Now we have got A1, A2, B1, B2, C1, C2. All the values, all the direction ratios are with us. Already they have said us the two lines are perpendicular, that means they are meeting at the right angles. So the condition is A1, A2 plus B1, B2 plus C1, C2 should be 0. So we are taking that is equal to 0 because already given it is perpendicular. Now we should find the p value. So for that we substitute. A1 is minus 3, here A2 is minus 3p by 7 plus B1 is 2p by 7 into B2 is 1 plus C1 is 2 and C2 is minus 5. Say this is equal to 0. Now simplify. Minus into minus, it will be plus. 3 3s are 9, 9p by 7. Here it is 2p by 7. Here plus into minus plus, that is minus 10 is equal to 0. Here total 11p by 7. I take this minus 10 there, so it will be changed to plus 10. Now I have 11p by 7 is equal to 10. I need only p, so I take these constants to the other side. 11 by 7 will be written as upside down 7 by 11. It is equal to 70 by 11. So the value of p is equal to 70 by 11. In this way, we have to find the constants if they are given with some conditions. So this model is one of the most important models in NCERT book as well as in the CBSE examination. Thank you. We will meet in the next class with another model, how to find the distance between two straight lines.